Alright, let's look at equations of motion using normal and tangential coordinate systems now. We're also going to introduce this thing called the binormal. If we have a particle in a path, let's put that particle right here. If you remember, let's just pretend we're looking down on like an XYZ plane. Towards the center of curvature, we will have a normal direction. Tangent to the path, we will have a tangential direction. But the new one, these are both 90 degrees to each other. The new one is what we call the binormal, and it's going to be 90 degrees to both of those. So 90 degrees to that, and 90 degrees to that. Or orthogonal to the two. So first, we should note there's no motion in the binormal direction. We use it to sum forces, but there will be no acceleration in that direction, so the summation of the forces will be 0. We'll use it to calculate things like friction or things like that, though. If we know the normal force and the weight, we'll use that to calculate what the friction is while it's going around the corner, how much friction it needs to hold the corner of a certain radius, kind of thing. I'll even do a problem about banked turns. So if you're going down the highway and there's a curve in the highway, there's a reason. It's so that you don't have to put any steering input in. There's some certain angle and some speed that you can go around this corner on the highway without even touching your steering wheel. And let's figure out how to do that. And we're going to use this coordinate system to do it. Okay, so if we take Newton's second law, summation of the forces is equal to the mass times the acceleration. In this case, we have to consider the unit tangent direction, the unit normal direction, and the unit binormal direction. So, doing so, I can get the summation of the forces in the tangent direction times the unit tangent plus the summation of the forces in the normal direction times the unit normal plus the summation of the forces in the binormal direction times the unit binormal, and that's going to equal to the mass times the acceleration of the tangential plus mass times the acceleration in the normal plus 0. And these are vectors. Each one of those has a direction, as well as all of those are unit vectors with a summation of forces multiplied in front. Now if I take this and this, and this and this, and this and this, we get a new way to sum forces in normal and tangential coordinate systems. So the summation of the forces in the tangent direction is equal to mass times the acceleration in the tangent. The summation of the forces in the normal is equal to mass times the acceleration in the normal. And then we get one more. The summation of the forces in the binormal direction is equal to 0. And so we'll have to do some examples before that makes sense, in my opinion. Just off the top of my head, it doesn't make sense unless I showed you an example. The only unknowns is like, what do we call this? Well, we looked at this last semester. The tangential acceleration is literally how fast you're speeding up on the path, or dv/dt. We also need to know the normal component of acceleration. We found that as v squared over rho. So don't forget that, and we also used the fact that the radius of curvature was equal to 1 plus the first derivative squared all of this to the 3/2 divided by the second derivative. So everything we learned in chapter 12 in tangential coordinates works in here too.